Hello students, good morning and welcome to my another video and welcome to my beautiful channel TopClass Physics. So today I have taken a very beautiful question that is written here, and this is of course from electricity capacitance part, you know. And it seems like a very difficult question, that is the figure that is drawn here, but this is not that much difficult. And I must say, after solving this question, after seeing the whole lecture, you must say that it was super. Actually, my purpose is not only just solve this question, my purpose is to give all types of concept behind this question, and after getting that concept you can apply in various question to solve, and it will be more easier for you. Okay, so let's start. So your question is, the plate A of a parallel plate capacitor, because you know this is a parallel plate capacitor, is connected to a spring of force constant K. This is the spring is here, and the force constant is K, and can move while the plate B is fixed. This plate can move because this is connected to a spring, and this plate, this is B plate, it connected to a rigid rod. This is a rigid rod, you can say. This is not movable plate, this is a fixed plate. Okay, if a charge plus Q, and you can see this is a rigid support, this is rigid support also, so these are rigid support, they can't move. Only this is also fixed, only this plate can move. If a charge plus Q is placed on plate A, so this is a plate A and the plus charge is given here, and minus charge minus Q on plate B, minus charge, this is minus Q charge and this is plus Q charge that are given. By how much does the spring elongate? After giving these charges, so how much does the spring elongate? Okay, in first, whenever charge was absent, the spring was in initial position. Now after giving the charge, how much does the spring elongate? The area of the plate is given, that is A. Okay, the plate area, this is not line, this is a plate, this is also a parallel plate, this is also a parallel plate. Okay, and the area of that plate is A. Clear? Now let's start how to solve it. First of all, here two concepts needed, that is, one is spring concept, another is capacitor concept. Okay, so suppose if I take a spring, this is a normal spring, and in normal condition the spring constant is K. Now if I elongate it like this, elongate by, say, this is L, I elongate it by L. This is a normal position, this is 0, and I elongate it by L. So spring constant will be, what is the spring constant? This is spring constant, sorry, the force. For the force in this spring, the force is spring constant K into the elongate part, that is elongate length is L, that is K into L, and negative sign will come. Why negative sign? Because if I elongate in this direction, the spring constant is applied in this direction. This is F and this is L direction, because the force is vector quantity, and if I take L is a vector quantity, you can say L direction is L in this, how about this is a positive X direction, and force direction is in negative X direction. This is the elongate, because if I stretch the spring like this, the force will apply by the spring towards, now this is a fixed point. If I elongate a spring like this, the force will be applied in this direction. I elongate part, so elongation direction is this, towards this, the force will be applied in this direction, so they are opposite. That's why negative sign will come. Okay, this is another concept. This is one concept, and another concept is, this is capacitor part. Okay, so here you can see, this is a capacitor here. In initial condition, the spring is attached in this plate, all okay. Now if I put the charges in A plate is positively charged, B plate is negatively charged, so what will happen? Just think what will happen. This is negative charge, this is positive charge, this plate is fixed, this is not fixed, so negative charge will attract positive charges. That means B plate will attract A plate. Clear? So what will happen? This plate will attract by this direction, by B plate in this direction, and it will shift it like this. So this spring is now elongate like this, So this is the initial position and this is now the final position, and it elongate by the distance say L. Clear? This is now the final position and spring is elongate. Clear? So our question is to find the L value. What is the value of L, or what is the equation of L? Clear? So what will be the spring force? F, because spring force is towards in this direction, and elongate, the spring is elongate in this direction, so they are in opposite direction, so minus K, the spring constant is K is given here, K into this spring elongate by this distance L, that is L. So this is the force, this is number one equation. Clear? Now this plate is now here, this is our final position of the A plate. Now see, this is positive plate, this is negative plate. As we know, any two plates, suppose these are positively charged and negatively charged, they are separated by a distance say D, right? One capacitance will occur, that is the capacitor action will occur. So the capacitance is epsilon naught, the area say A, that is epsilon naught A divided by the separation by the distance say D, this is D, then the capacitance will be C equals to epsilon naught A by D. Clear? So same here. So if I take the distance, say this is X, if I take the distance between these two plates after elongate, the separation distance is X. So what will be the capacitance between these two plates? Because this is a positive plate, this is negative plates. This A plate is now here and this is B plate. So capacitance will be epsilon naught, the area of plate is A, that is A divided by the distance between these two plates is X. So this is the capacitance between two plates. Clear? Now just calculate the energy stored by this plate. Energy stored, U. What the value of U? That is half Q square by C. Right? Half Q means the charge of any plate, the magnitude value of Q, charge value is Q, the square, and divided by C, the capacitance, the value of C. So why it needed? Because I am to find the force. I am to find the electrostatic force between these two plates. And we know that force will be equals to this force, spring constant force. Right? This force is due to the spring constant, because this spring is elongate, the force is this. And the electrostatic force between these two plates due to the charge, that force will be F equals to minus du by dx. Right? And why this negative sign? Because this force is attractive force, not repulsive force. If two plates are positive, same charge, then that force will be positive. This force is repulsive. And this is a C, this is positive and this is negative charge. That means the force is attractive, that's why the negative sign will come. So this is the potential energy stored, U, and the X is the function, distance between them, the function of that force is the function of X. So just put over here du by dx. So instead of U, just put over here, that is half Q square by C. Right? So if I put the value of C, then epsilon naught A by X, so X in a numerator. Just derivative it with respect to X. You know Q is constant, area is also constant, epsilon naught is constant, half also constant. So if I remove it outside of this derivative part, then our this is electrostatic force. Electrostatic force. Right? Electrostatic force between these two plates, because these two charges are opposite, plus and negative, that is minus is come, and that is du by dx, the electrostatic force equation. Now just put over here and just derive it. So half will remove Q square by epsilon naught into A, and dx and x is remaining here. Okay? Now if I did not this type of calculation here, if I derive it x with respect to x, it will come 1, that is minus half Q square by epsilon naught into A. So this is the force between these two plates, and this force will be equals to this force. This is the this force due to the spring, and the electrostatic force must be equal. That means this is minus K into A. So I have to find the value of L, the elongate. How does the spring elongate? So I have to find the value of L. Okay, so just minus will go on, and L equals to, this is divided by K. That's it. So L value is now this. Clear? This is very easy. Just and if in JEE Main or JEE Advanced they asked you that find the value of L, and they given the value of Q, suppose something, and value of epsilon naught, you know, area value is say 2 meters square or 1 meter square, whatever. K value is given, spring constant. This K is spring constant value. So you can easily calculate the value of L in centimeter or meter, whatever. So you can just put in, fill in the blanks. Okay. So this is the concept behind this question, that you have to apply the spring constant, spring force, that is minus K into L, and you have to calculate the force between these two plates. If you know the energy stored between these two plates, then you can easily find the force between these two plates, that is electrostatic force, right? And these two forces are equal, then you can equate it and easily find the value of L. Clear? So that's all for today. Thank you so much for watching this video, and please subscribe this channel and share with your friends. Thank you so much once again.